Okay, so rotating counterclockwise. I've traced it all out. Got my little crosshairs. Remember, hold your pencil down there. Counterclockwise would be this direction. They want us to go 90 degrees. So basically keep rotating until that crosshair lines up again. And I'm just going to shift it over and get it good and lined up. And now I can see where my points would be. And what I will usually do is just kind of sneak my pencil underneath the tracing paper and draw those dots where they're supposed to be. And now I've got my new shape. Now, if I did this on my test, I've got a lot of my points, but I lost some easy points here. What could I add to this to improve my score on this, Foley? I could put the letters on it. What do I need to put after each of those letters? I put the little prime notation. So I'm actually going to go over today at the end of class. I'm going to tell you exactly what's on the test, page by page. And I will tell you right now, though, that page 3 is you're going to be doing this. You're going to be doing a reflection, a rotation, a translation, and then a fourth one, which will be one of those repeated. And it says at the top of the page, label your new shape using prime notation. And then it says at the bottom of the page in bold, big font, stop. Did you remember to label your figure using prime notation? But I'll tell you that a lot of people did not do that and missed points last year. I got those backwards, didn't I? A would be this one. C would be this one. So just make sure that you remember to do that. So there's my rotation. Is it on that? Part BS is to reflect it over a line. X equals 1. I need you to know that when you see the line X equals, that's a vertical line. And this is an X equals, so it's going to cross the X axis at 1. So we're talking about this vertical line here. And they say to reflect ABC. So that's the original one, not A prime, B prime, C prime, but they want us to do ABC. The prime is the new one. Original one would not have primes. And do you know the kind of the cheat code for doing this without tracing paper? Have you figured out that you can just like take a point and count over to the line and then count the same amount on the opposite side and make the new points? Have you figured that out? So a lot of you have been using this already, but check it out just in case you haven't seen this yet. So C, I can count as 1, 2, 3, 4 spaces away from the line. I can just go to the other side of the line and go 1, 2, 3, 4 and draw a point there. That's going to be C prime. It's going to be on the opposite side of the line, same distance away. C prime prime. Yes, thank you, because we've already got C prime down there. So C double prime. Thank you. And then B is 1 space away, so B double prime will be 1 space away on the other side. And A is 1, 2, 3, 4, 5 spaces away. So I'll go 1, 2, 3, 4, 5 spaces away on the other side and get A double prime. So you don't really, if it's, now this gets trickier when it's a diagonal, right? When it's a diagonal, this is a little bit tougher to pull off. But if it's a horizontal or a vertical line of reflection, you can just count to it and count on the opposite side. So that's part B. And then part C is to translate. And again, it's triangle ABC. So we're going back to the original one. So that A triple prime is at 4, negative 5. So here's 0, 1, 2, 3, 4, 1, 2, 3, 4, negative 5. So we want A triple prime to be down here. A couple ways you could do this. You could count and see how do we get from A to A triple prime, and then just do the same thing with B and C. So I could count and say that I would go over by 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2, 3, 4, 5, 6, 7, and then just do that for B. So over 8, 2, 4, 6, 8, wait, 2, 4, 6, 8, and then down 7 would end up being right here. Or the other way to do it is notice that the relationship between A and C is to go from A to C, I go up 4 and over 1, and I could just do that here as well. Up 4 and over 1 would get me to C triple prime. So however you want to do that, that would be our translation. And then we can figure out what B triple prime's coordinates are. I'll leave that last piece to you. So there's 116. Thanks for someone emailed me about, I can't remember who emailed me, but thanks for that email. What others do we want to go over? Yes. You don't have, oh yeah, we're 10 minutes in. Thanks for waiting. Sign up, take fast. I was gonna say you don't have to ask for permission. What other questions do we have from homework? Knowing that our test is coming up here soon. Other questions? Yes.
When you get like 0 over like
When you get 0 over something, 0 over 5,
yeah.
That's 0.
Oh, like, what's the one that you put in the file? Oh,
Because we can't divide by 0. So when we divide by 0, it's undefined. But you can divide 0 by whatever you want to. I have $0 and you all get a piece of it. You all get $0. But if I have $5 and I want to split that up between 0 people, that's just not possible. Well, but where does it go? It's got to get split up between 0 people, so it has to leave my hand, but it needs to go to 0 people and evenly split up. Don't think too hard about this, because if you could actually accomplish this, the universe would collapse on itself and everything you know and love would cease to exist. You can't divide by 0.
well, yeah. I'm giving $5 to 0 people, then I would magically disappear into then $5 goes down.
But it would still be there. It's got to be given away to. Yeah. You're right. The key word in your explanation is magic. Yeah, if we introduce magic into it, then yes, we can. But it physically and mathematically doesn't make sense to divide by 0. So we say it's undefined. All right, other questions? Good question. I'm gonna get your answers here in a second, but let me come around and check your homework. So let me pause this up here. So what we're gonna do today is gonna be super important, because we're going to fill out the Shapes toolkit. Now, I asked you on Friday when we were using this to not write on it. Some of you may have, and if you did, that's okay. Hopefully you've got some space so you can just kind of work around what you already wrote. We're going to fill this out today. Now, at the end of the class today, I'm going to show you, or I'll tell you exactly what's on the test. And you're going to find that like a whole page of the test, you're going to want to have the Shape toolkit out. In fact, there's like a whole bunch of questions on it where like literally all you're doing is matching the shapes here to their names. And if you've got this in front of you, it's going to be super easy. Okay. So this Shape toolkit is like probably the #1 reason you do not want to forget your packet on test day, which is Monday. All right. So what our goal today is to mark up these pictures and write out what the properties are. Our learning targets are about finding the properties of shapes. So for all 16 of these shapes, we're going to write down what their key properties are. I want to just remind us of a couple of abbreviations that we've been using, some symbols, and I'm going to introduce a new one to you today. How many people have seen this symbol? It looks like an equal sign with a little squiggle over top. Have you seen that before? Do you know what the word for it is? It starts with a C. It is congruent, yeah. Oh, okay, awesome. Use your resources. I'm impressed. And congruent means what? Same length, same size, basically. I'm going to write same size because it can also refer to angles. So same size. Now we're going to spend some time really getting into what congruent means later on. But for today, we're going to use this symbol when we're talking about two sides that are the same length, just so we don't have to write out the letters for same length every time. So congruent. We have talked about this symbol already. Just a quick reminder, that is not the number 11. That means what? Parallel. And we've talked about this symbol before, kind of an upside down capital T. And we're all comfortable that that symbol means, I hope, perpendicular. I just want to remind you of the notation that we use. If I'm dealing with, for example, an isosceles triangle that has two sides that are the same length, what do we do visually to mark those sides? We put little tick marks on them. There is a way to mark parallel sides too. Do you know how if I've got two lines that are parallel, do you know how we mark them parallel? Instead of ticks, we use little arrows. Anytime you see a little arrow, that means you're dealing with parallel lines. A little bit further down your page, look for the rectangle. Do you see how it's got single tick marks on the left side and the right side to indicate that those are the same length? But also it has single arrows on the left and the right side to indicate that the left and right are parallel. And then double tick marks on the top and bottom telling you that those are the same length, but not the same length as the left and right. Same thing with the double arrows. Good. And then perpendicular, if you remember, means that it makes right angles. And we indicate that with a little box. So our goal for today, the main thing I want you to do is we're going to fill this thing out. I will provide you a key that you can check against when we come back in and review on Thursday. But we want to try and see if we can figure as much of this out on our own as we can. I'm going to work through you on a couple of them. I'm going to work through with you on a couple of them. And then I'm going to have to work with your group to fill out the rest. So here we go. Equilateral triangle. What do you think special about the sides of an equilateral triangle? All three sides are the same. So I'm going to put a little tick mark on all three sides here. So first thing we'll look for is congruent sides. And I got this list up on the whiteboard up here. And I would say all three sides congruent. All three sides are the same length. Are there any parallel sides in an equilateral triangle? Actually, is it possible for a triangle to have any parallel sides? Pretty sure every side intersects with the other two, right? So no parallel sides. We won't bother with that. Any? If we have multiple triangles stuck together, yes, which is what we did in lesson early last week. Yes, but a single triangle, I think we can agree, can't have parallel sides. Not on a plane, anyways. Now we get into spherical and hyperbolic geometry in your college level geometry classes. All that goes out the window. But for right now, okay. How about right angles? Any right angles? No. Any perpendicular? No, perpendicular goes with right angles. Is there any symmetry? I'd say yes, it does have reflection symmetry. So I'm going to abbreviate that REFL for reflection symmetry. SYMM. You do you. I probably, if I tried to write those words out, it would fit in there. Some of you have very small, neat handwriting, though. You could probably write out reflection symmetry. And we could draw several lines in there, but for right now, I'll be content to just say it has reflection symmetry. Does it have rotation symmetry? Yeah, I could rotate this and get it to look the same. Notice it's flat on the bottom and pointing up. If I rotated it around to here, look, it's still flat on the bottom and pointing up. It looks the exact same. So it has rotation symmetry for sure. Rotation symmetry. And how many degrees would we have to rotate it to get it to match up again? You don't remember how to do that? 120, what are you doing in your head? I'm going to put a little thought bubble out here. What are you doing in your head to come up with that 120? Okay, so 360 divided by 3 is going to give you that 120. Because there's kind of three patterns going around the triangle with three sides. Cool. We're just going to do that with all of them. Let's do a couple more together. Let's do the scalene triangle together. Scalene triangle have any congruent sides? Nope. Any parallel sides? Nope. Any 90-degree angles? Nope. Any reflection symmetry? Nope. Any rotation symmetry? No. Wow. There's not much special about this. It's scalene. So what could we say? I feel like I want to write something about it. I don't want to like leave it totally left out. It'd be mean just to leave it. I want to write three, and they're all different lengths, right? Three sides, different lengths. All different. I feel mean just leaving it blank. Well, you'll see some shapes do have feelings. Anybody ever seen the movie Flatland? We'll watch that later on. Yeah. Yeah, it's about shapes and they do have feelings. Oh, yeah, stuff like that. No, we're not watching Donald. Everybody wants to watch Donald Duck at Math Magic Land. That's it's a great movie for like elementary school math. But
Yeah.
all right, well that's practically elementary school. Okay. Let's do square. Anything special about squares? Sides got, I would say, let's talk about sides first. Congruent sides, 4 of them, right? 1, 2, 3, 4. So all 4 sides congruent. Someone need to pull their phone out and silence it. It's okay if you need to do that. Happens. Parallel. Yeah, we got parallel sides. Are all 4 sides parallel? Ooh, no. The left and right are parallel. Like this and this are parallel. And the top and bottom are parallel. So I'll put double arrows on one and single arrows on the other. But they're not all 4 parallel to each other. I would say for this, I would say opposite sides parallel. That's how I would describe that in words. Any 90-degree angles? Boy, I didn't leave myself a lot of room here for a couple of these. There's a 90-degree angle here and here, and here and here. Those are tiny. So I would say 4 right angles. Reflection symmetry. And rotation, you said? And how many degrees for that rotational symmetry? 90 would work. 90 would 180 also work? And 270. So basically any multiple of 90 degrees. So 90 degrees. I'm just gonna write 90. But you know what I'd say, when we say rotational symmetry of 90, you can keep adding 90 onto itself and any of them would work. Same thing with 120. What would be the other angle that we could rotate the equilateral triangle other than 120? Keep adding 120 plus another 120 would be 240 plus another 120 gets us up to 360. So I would say 90 degrees, 180 degrees, 270 degrees. Just keep adding 90 and you get more. Let's do the rectangle while we're here. They kind of took up a bunch of room here, and I apologize on behalf of the person who took that in. This is very similar to the square, but a couple things are different. Are all 4 sides congruent? I would say opposite sides are congruent. I would say opposite sides are also parallel. So opposite sides are congruent and parallel. We've got our 4 right angles here. That's cool. What else do we want to talk about? I'm looking at my board, my list on the board here. Oh, symmetry. Reflection symmetry? Yep. A couple different places. Yep, I've got, well, I just underlined the 4 right angles, but if you wanted to write something about adjacent sides or perpendicular. By the way, do you know what adjacent means? Adjacent means next to. So when you get to kite, you're going to say adjacent sides are congruent. What about rotation symmetry on the rectangle? Yeah. It also has rotation symmetry of how many degrees? Not 90 this time, but 180. All right, you get the idea here. We're going to mark up the pictures. We're going to write in the properties. And then when you're done with that, you're welcome to start the homework assignment. What questions do you have for me? Are we feeling pretty good about what we're going to do today? All right, so yeah, we're going to do this for all 16. So when you're finished with that, you're welcome to check with me. I want you to go ahead and start on the homework. Guys, pay attention to this really quick. There's some confusion first period today. The homework that's due next class is 1.3.2. However, you're going to have a homework assignment on Thursday. You will have the entire period Thursday to work on this. But notice it is much longer than our normal assignments. 128 to 137. That's how many problems? That's 10 problems. Isn't it? I think it would be 9, but it's actually 8. Or it's actually 10. Well, it is actually 9 because 137 is just to check your answers. And the answers are in the book. They're right after the last problem. You should check as you go. So the reason I'm putting this on our sheet today is some of you are going to get this done like in class today. If you have time, I highly recommend that you go ahead and start on the closure so that you can come to class on Thursday and ask some questions. Okay, because you're probably not going to have time to finish all of the closure in class on Thursday. Let's say you only do the first half in class, but then you end up having questions on the second half. Well, then it's kind of too late at that point to ask questions. So I recommend that you start on the closure before class on Thursday, knowing though that you will have the whole class on Thursday. Okay.